Hello, everybody. So we are going to move on to complex numbers. Now, some of this you've seen before in the past, and some of this it might be new. I'm not sure. I can't remember if it should be new or not. But so let's talk about what we're going to go over in this section. So we are going to look at adding and subtracting complex numbers, and then we're going to multiply some and then divide some, and then we're going to perform operations that deal with square roots. Okay. So those are the topics that we're going to go over in this section. So let's jump right into this. Complex numbers. Well, what is it? When we talk about complex numbers, we talk about imaginary numbers. An imaginary number is basically the square root of a negative number. I, in particular, is the square root of -1. So if I have an imaginary number, I'm having the square root of the -1. And then if I square that, my answer would actually be -1. When we look at complex numbers, we look at it as a combination of a real number and an imaginary number. That's why it makes it complex. So when you add those two together in the form of a plus bi, that is actually your complex number. The standard form, oops, didn't mean to do that. The standard form of your complex number, again, is going to be in this form here. So standard form is some random number plus bi. Complex numbers is real numbers mixed with imaginary numbers. Okay, so that's what they are. Now, before we get too far into this, let's talk about specific imaginary numbers, because there's a pattern that evolves here. So if I start here with this imaginary number and I say I to the first power, what is that? Well, that answer is I. I to the second power, well, we know that I squared, because I just told you this is right here. I squared is -1, so I squared is -1. I to the third, well, that's this times that. When you multiply these two together, you get this piece here. And then I to the fourth is this number here squared, and that's where that one comes from. And then the cycle repeats itself. So I to the fifth, I to the sixth, seventh, and eighth, ninth, 10th, 11th, and 12th, so on and so forth, all the way through this whole entire cycle. Now, when you take the ACT or the SAT or any other type of college entrance exam, there might be a question that you might see on there that looks like this: I to the 2019 power. Basically, what that's asking you is which one of these four answers that are right here is going to be the answer to this, because there's only four possibilities to this. So how do we figure this out? So what we do is we take our 2019, we are going to divide that by 4. Okay. That leaves us, so 4 goes into 25 times, 4 goes into 19, 4 times? So that leaves me with a remainder of 3. So if I'm looking over here at this is a remainder 1, remainder 2, remainder 3, and then no remainder. So if this had been like 2020 divided by 4, I would have a no remainder, so my answer would be 1. But because this has a remainder of 3, I to the 2019 is going to be -I as your answer. So again, there's only 4 possibilities. So when you see this right here, take it, divide it by the 4, and then whatever the remainder is, that will be your answer to this problem. Okay. So let's talk about operations. When we talk about operations, we talk about add, subtract, multiply, and divide. And you're saying, well, wait a minute, what about division? Yes, division is an operation, but that's a whole different mentality when you go into it, because you can't simply divide the top by the bottom to get an actual answer. So we're going to deal with the first 3 first, add, subtract, and multiply. Go through those processes so you can see exactly what's happening, And then when we get to division, I'll show you a different way how you'll have to approach that. So when we add or subtract, it's extremely easy. It's just like if I gave you 5x plus 12 and I wanted you to add that to 7x minus 3. Literally, numbers go with numbers and letters go with letters. It's the same thing when you're dealing with this. Numbers go with numbers and eyes go with eyes because you can't mix them up. Okay? So if I'm looking at this, the 5x minus 2 plus 3 plus 3i, well, the plus sign says there's nothing special that I actually have to do, so I'm just going to be able to combine like terms on this. So this 5 is going to be added to that 3, and that gives me an 8. And this negative 2i is going to be added to that 3i, and that's going to give me plus I. And that's my answer. Okay. When I get to this one, and notice here I'm subtracting, well, in order for me to subtract, I have to distribute first. So I'm going to leave this 2 plus 6i alone, distribute my negative, and now I'm going to combine like terms. This 2 goes with that negative 12, gives me negative 10. And this 6 goes with that I. Remember, there's an imaginary 1 sitting in front of this I that you don't see. So that leaves me with a plus 7i. So really, when you add or subtract, all you're doing is combining like terms. Okay. Multiplying. Multiplying, for the most part, is relatively easy. You're going to do the same things as you've done before. The only difference is that you have an I squared. We know that I squared is equal to negative 1, so you actually have to do the conversion on that piece. So, start with the first one here, the 7i, and we're going to distribute that to both of those. So we get 7i times 2 minus 7i times negative I. So on the front piece here, I get 14i. And on this back piece here, I get 7 times 9, that's negative 63. And then I times I is I squared. Well, I know what I squared is. From the beginning, when we looked at our pattern, I squared is negative 1. So what I'm really looking at is 14i minus 63 times negative 1. So I'm looking at 14i plus 63. Okay. Now, you can leave it like this. Just be aware that it's always going to be in the form of a plus bi because your I always comes second. So you can rewrite this if you need to into that form, but just know that both of these mean the same thing. Okay. On part B here, we are going to FOIL this out. So that 5 will go with that 6. That 5 will go with the 7i. That 4 will go with this 6. And this 4 will go with that 7i. So we'll start with the red. 5 times 6 is 30. And then we'll go to the green. 5 times negative 7i is negative 35i. Then we'll go to blue. 4 times 6 is positive 24i. And then we'll go to black. And that will give me 4i times negative 7i will give me negative 28i squared. So now, with that being said, what we have to do now is that we can't leave it like this. So we have to take this piece right here, and we know, again, that I squared is negative 1. So I have to fix this whole back piece right here because you can't have multiple i's in here together. So I'm going to clean this up some. So we'll go 30. So 35i negative plus 24i, that will give me a negative 11i. And then minus 28 times negative 1. I have to keep cleaning this up. So 30 minus 11i plus 28. Keep cleaning it up. That gives me 58 minus 11i. And then I am done. Okay. So when you're multiplying these, remember you can't have I and I squared all together. You have to get rid of that I squared. You have to simplify this down as best as you possibly can. That's the whole goal, because remember, you can only have a number and an I. Those are the only two things that you can have. All right. So let's talk about conjugates. So hopefully you remember a little bit about this. And conjugate, we normally talked about this when you're trying to rationalize a denominator, when you're having square roots. You would multiply the top and bottom by the conjugate or whatever. In this case, we are going to have what's called a complex conjugate. So that's saying that if I have an A plus BI, I have to multiply top and bottom by an A minus BI. Okay. So when you go through this process, you actually will wind up on the bottom with an actual number, because just like with square roots, you can't have a complex number in the denominator. You actually have to have an actual number. So your denominator will be this right here. It will be an actual number, because if you look at how you fold everything out here, notice that this piece here will go away, leaving you with just the number. Okay, so let's take a look at this. If I have this piece here and I say, okay, what I need to do is I can't divide this as is. I need to go through here and I need to multiply top and bottom by the conjugate. So what I do is I come over here and I say, okay, my bottom is 4 minus I. So that means I'm going to multiply top and bottom by 4 plus I. You have to multiply top and bottom by 4 plus I. On the bottom, you're going to wind up with an actual number. You wind up with 4 minus I squared. Remember, I squared is negative 1. So you wind up with 4 minus a negative 1. So that gives you 4 plus 1. So we're going to wind up with something over 5. On the top, we're just simply going to FOIL this out. So we wind up with a 20 plus 5I plus 16I plus 4I squared. Then we're going to combine, I forgot the I here. Hold on. There we go. We're going to combine our like terms. So 20 plus 21I plus 4I squared. Remember that the I squared becomes a negative 1. So really what we're looking at here is not a plus 4I squared. We're looking at a negative 4. So on top, we wind up with 16 plus 21I. And so when we finally clean everything up, we wind up with, 21I. We wind up with that as our final answer. Okay. So make sure when you go through this process, you can't stop here. This is a no. You can't stop there. You have to keep going, because you cannot have an I and an I squared, because we know I squared is negative 1. That's why this back piece right here, that's why that plus 4I squared went to a negative 4. And then when we did this piece here, 20 and negative 4, that's where the 16 comes from. Alrighty then. So we looked at what is an imaginary number. We looked at the pattern of the 4. We looked at how to add, subtract, multiply, and divide. So now let's talk about what the principal square root is. Basically, what this is saying is what happens if I have a square root that has a negative under the sign. Well, remember that negative is going to wind up being, because if you remember, this is really negative 1 times b. Well, what is negative 1? Negative 1 is I. So you'll pull out that I so that way you can deal with the square root normally, because you can't have a negative under the square root. We have to get rid of that first before we can start simplifying and everything else. So if I have problems like this, I have to get rid of these negative signs here and here. I can't keep them there. So I'm going to start with this 27 first. So I'm going to pull out that -1, square root of 27. And then the 48, the -48, that'll be I square roots of 48. Now I can deal with that square root of 27 and the square root of 48. I can deal with those, and that way I can get rid of things and go from there. So if I'm looking at this, I need to basically, I'm going to start with this 27 piece here first. I need to simplify this 27. Well, that becomes 9 times 3. And then the square root of 9 goes down to 3, and this 3 will sit there. So really what I'm looking at will be I with a 3, and then a square root of 3, because that 3 is here. And this is your leftovers, so that stays on the inside. Oops. And then under the 48, we're going to do the same thing. Well, the 48, its biggest perfect square is 16. So that's 16 times 3, so that gives me a 4. So then I want to say plus 4i square roots of 3. Ooh, I don't like that 3. Plus 4i square root 3. Now, I have 2 square roots of 3, which is good because I can't say as it sits right here, I can't add those together because they have nothing in common. I have to make sure that both square roots are exactly the same. So then I'm just going to keep my square root of 3, and then I'm going to say 3i plus 4i, and that gives me 7i. And this would be my final answer. Okay. Coming over to part B. So remember that this piece here means I'm going to have 2 sets of these. And remember that instead of saying the square root of -3, we're going to say the I square roots of 3. So we're going to come over here and we're going to say -2 minus I square roots of 3 times -2 minus I square roots of 3. And then we're going to FOIL this out. So -2 times -2 gives me a positive 4. -2 times a negative I square root of 3 gives me a positive 2i square root of 3. And then this one times this one gives me another positive 2i square roots of 3. And then this one times this one gives me a positive I squared times 3. Because remember, square root of 3 times the square root of 3 will actually give me 3. Let's clean this up a little bit. So I have 4 plus, I'm going to combine these two together to get 4i square roots of 3 plus 3 times -1. So 4 plus 4i square roots of 3 minus 3. So my final answer would be 1 plus 4i square root of 3. The key thing here is making sure that you are foiling correctly and that you're keeping your terms in order and making sure that you don't stop right here. Make sure that you're taking this I squared that's right here and you're turning that into that -1, because that needs to happen. If that doesn't happen, then you can't complete the problem. So please make sure that you're taking that I squared and you're turning that into the -1 so that you can complete the problem, because remember, your goal is to have an answer in that format of some way, shape, or form. Okay. That's it for complex numbers. I hope that wasn't too hard, and I hope that was kind of a nice refresher of how we deal with those. So now what your job is to do is log into Blackboard and go into your homework section and start working on section 1.4 called complex numbers. Make sure you are emailing me and sending me reminders if you have questions. And don't forget to click that Ask Your Instructor button. That is, I think it's on the right-hand side, so that way it will email me. And if you do, I can't say this enough, if you do, please make sure you send me something saying, hey, I clicked the Ask the Instructor button because I had questions, because it doesn't go to my Paris High School email. It only goes to my PJC email, and I don't get notifications for that one. Okay? So I hope all is going well, and if you need me, you know how to get a reach to me. So I will, I guess, see y'all in class. TTFN. Ta-ta for now.